All right, everyone, this is the biggest one of them all, and it is probably the most important way of thinking about the average in terms of providing insight with where we are going. I showed you how SUMPRODUCT works. In the last video, we saw 3 different ways to go about just kind of creating an average. I mean, equals average was one of them, but we could add up all the values of the observations, divide by the frequency of observations, total frequency. There was this other version where we took a sum product. We took the observations and multiplied them by their frequency and added up. But now we're going to do this special way that is going to be so impactful. We're going to take the relative frequency. We know we have 31 observations, right? So I'm going to take my value and just divide by 31 observations, and I'm going to sort of slide that down, that formula, and, let's dress this up a little bit. So we get 6.45%, 9.68%, 25.81% of the time I had 2 full glasses of water, etc. Well, look what happens if instead, before I had to take some product and get the total number of glasses of water, and then I divided at the end by the number of observations, 31. But here I've already divided, haven't I? I mean, that was 25 divided by 31, and 2 divided by 31, 3 divided by 31, 8 divided by 31, etc. So that's kind of the 31 in the denominator is already baked into the cake, as it were. And a couple different ways of thinking about this. One, I could multiply each observation by its relative frequency. I'll go out here a little bit, add more decimals, and as I go down, look at what happens. Equals sum I-25 to I-33. I get 3.68, which is the average we've had all along. Notice only in this example, I don't need to divide by 31 because I divided by 31 every single time with each of these values. So what's the interpretation? What's going on here? I am multiplying the observation by its relative frequency, and by doing that, I am effectively giving it its probability weight. And so, hey, the observation was 1, and one happened 9.68% of the time. And so we're going to treat that like 0.1. And 2 happened 25.81% of the time. So, that's almost 26%. 26% times 2 is 0.52. So that's going to be 0.52 units. And when we add all of them together, we get right to the true average, the true mean, each and every time. This is going to be massive when we get into expected value, because that's essentially exactly what we are doing. And so this interpretation of taking the average, as it turns out, is probably the single most important. One last quick trick. I have my observation column, which is F25 to F33, and I've got my relative frequency column, which is H25 to H33. And what I'm going to do is I'm going to do a sum product equals sum product, parentheses, F25 colon F33, comma, H25 colon H33, parentheses. And I get my 3.68. So just multiplying each of these through via the sum product, I actually don't need this probability weighted observation column at all.